Question 9. So this is a question with a normal distribution. We have a bakery which makes two types of muffins, chocolate and banana, and the weights of the chocolate muffins, so C will be the weights of the chocolate muffins, is normally distributed, and the mean of the distribution is 62 grams, and the standard deviation of the distribution is 2.9. And now I write it with square because usually here is the variance, which is the standard deviation square. And we need to calculate what is the probability, what is the probability that the weight of a chocolate brownie is less than 61 grams. So this can be calculated using the calculator, but since there are different types of calculator, I'll give you a bit more information. So what we have here is a normal distribution. The center of the distribution is where the mean mu is 62, and now we have the brownies that the muffins that are less than 61 grams. So if here 62, here will be 61, and the probability is the area under the curve. So we just need to calculate the probability of having weights smaller than 61. So we go to the calculator, we input mu, we input sigma, and we input C. Yeah, this is 62, 2.9, and 61. We use the calculator, and it will give us the probability. So the probability that C is smaller than 61 is 0.365. So this is from the calculator, and this is the answer to A. B. In a random selection of 12 chocolate muffins, find the probability that exactly 5 weigh less than 61. So this is a question in binomial distribution, and one can see it from the fact that we have here 12 trials, that only 5 of them are where a muffin that weigh less than 61 is randomly selected. So in a binomial distribution, we have the parameters P, N, and X. P is the probability for a certain event. Here, this event is the probability of having a weight of a chocolate muffins that is less than 61, and we know that from A, this is 0.365. N is the number of trials, and we have here 12 trials. And X is the number of times that the event which have the P probability, this one, will happen. So we have here X equals 5, because we need that exactly 5 will weigh less than 61. So we ask, what is the probability that X equals 5? And for that, one can use again the calculator. We have to input all these parameters. So we input X equals 5, N equals 12, and P equal 0.365, and the calculator gives the answer 0.214. This is the answer to B. Moving on, now we have the banana muffins, which their weights are marked as B, and they are also normally distributed and have a mean of 68 and a standard deviation of 3.4, which means that the variance is 3.4 square. Each day 60% of the muffins made are chocolate. Now in one particular day a muffin is randomly selected. Find the probability that the randomly selected muffin weigh less than 61. Okay, so we're gonna do it in two steps. First, I need to calculate the probability that a banana muffin weigh less than 61. So this we already did in A, simply with other values for the mean and standard deviation. So I will repeat it shortly. I go to the calculator, I input mu as 68, sigma as 3.4, and B or X as the value 61. And I'm using the calculator to calculate the probability that B will be less than 61. So the calculator here gives the answer 0.2268. So this is just the probability of weighing less than 61 for a banana muffin. But this is not the end, because only 60% of the muffins 40% of the muffins are chocolate and 60% are banana. So we want to calculate the probability that a muffin weigh less than 61. So we have two options here. There is a 60% chance that it will be a chocolate muffin. And then if it is, there is also a certain probability that it will weigh less than 61. This was calculated in A and it was 0.365. And we have another option, that the muffin that we randomly choose was a banana muffin. For that the probability is 0.4, but then in order for this banana muffin to weigh less than 61, we have this probability. So sorry, now I realize I got here the wrong, I copied the wrong number. So the rest is correct, but the probability of a banana muffin to be less than 61 from the calculator is 0.01976. And therefore, here this should also be the probability. And now I can finish the calculation. And now this is the value of 0.2268. This is the answer to C1. And here I just want to say that this calculation, which I kind of presented rationally, can also be done using a tree diagram. So we can say that a muffin can be a banana or a chocolate. And then if it is a banana, it can weigh less than 61 or more than that. And also for the chocolate muffin, it can weigh less than 61 or more than that. And then we just put the right probabilities. So here, for example, for a banana we have 1.4, and for chocolate 0.6, and in order for a banana to weigh less than 61 we have 0.01976, and we simply follow the path of the tree that will lead us to the result where a muffin weigh less than 61. So we did this times this was one path, or we did this times this, what the probability here was 0.365. So these are the two paths that lead to the requested event. Now C2, given that a randomly selected muffin weighs less than 61, find the probability that it is a chocolate one. So since we have given something, so this is a conditional probability question, and we have this formula which I can write down right away. B is what is given, is the given event. So given that it weighs less than 61, we need to find the probability that it is a chocolate. So that it is C. So our first step will be to calculate this. This is the probability for the intersection of A and B, which means that the muffin is a chocolate muffin and it also weighs less than 61. So we already saw it in the previous part. A chocolate is have a probability of 0.6 to be a chocolate one, and then we have to multiply it by the probability that it will weigh less than 61. Yeah, that will be whatever will be. I will calculate it later. Now, P of B is the probability that a muffin will weigh less than 61. It can be a banana muffin, it can be a chocolate muffin. So this one was calculated in C1. So we know already the answer here, and this is 0.2268. So the final result, probability of A given B, is 0.6 times 0.365 over 0.2268, which is 0.965. This is C. C2. Now for the last part. So the machine is adjusted, and now a chocolate muffin is normally distributed with a mean of 62, but since the machine was adjusted, its standard deviation is no longer known. So I will write down sigma square. For the banana muffin, it remains the same. So the mean was 68 and the variance was 3.4 square. Now they say that the probability that the weight of a randomly selected muffin is less than 61 is 0.157. So again, we have the probability that a muffin is less than 61. So it's the probability that it is a chocolate muffin times the probability that this chocolate muffin is way less than 61, or we have the probability that it is a banana muffin and then the probability that this banana muffin way less than 61. Yeah, so I had some technical problems. So now let's put in the numbers. The probability of that is 0.157. Yeah, this is again what is known here. Now the probability that is a chocolate muffin is 0.6. And the probability now that this chocolate muffin weigh less than 61 is a variable. We're going to put it as P. We cannot calculate it yet because sigma here is not known. So we cannot just put in the numbers in the calculator and calculate the probability that C will be less than 61. And now the probability for a banana muffin, this is 0.4 times the probability that a banana muffin is less than 61. This can be calculated, and we already did it. And that was 0.019. So here what we have is an equation with P, and I solve for P and I get that the value, yeah, you just need to move the numbers to the left hand side and divide it by 0.6, and we get a P is 0.24853. Yeah, but what we need sigma. So we now know that the probability that a chocolate muffin weigh less than 61, yeah, this was our P, equals that. So if I'm going to plot it again, we have the normal distribution and the mu is known, is 62. Sigma is not known. We have here the value of 61, and the probability of C or X to be less than 61 is 0.24853. So now we're going to use the calculator, but instead of asking the calculator to give us the probability, which is here the area, we can also give it the area. So let's write it down. So we give the probability, we give mu, we give X or C, and we use the calculator to get sigma. But this is not so straightforward, so we cannot just input those value to the calculator and get sigma. I will show a few more steps that needs to be done. So what we can do with the calculator is to get the value here of the standard normal distribution. So for that we have the transformation x minus mu over sigma, and then we move from a normal distribution with a variable x to a normal distribution with a variable z, and z is standard, which means it has a mean of 0 and standard deviation of 1. And now we're looking for the value z1 that the probability of being less than this z1 value is 0.24853. This can be done using the calculator. So the calculator, if we going to give him a standard normal distribution with this probability, we will get that z1 is negative 0.679. So I will take this transformation, and z is 0.679. The value of x was 61. Mu was 62. And sigma is the variable. So I will use the calculator to extract sigma from this equation, and I get 1.4727, and this is the answer for D.